Okay, I'm going to give a brief introduction to the variable elimination simulation. So this is a simulation that, unlike some of the other simulations, uses a Markov network rather than a Bayesian network. And so a lot of the aspects of how we initialize this network are very similar to some of the other simulations. So for example, if we want to add a node, we can go to add a node and just type the name of whichever node we want to create. So let's create nodes A, B, C. And then we can also remove a node, press A, but actually I'm going to put node A back in. And then we can add an edge, so we can add edge from A to B, B to C. And these edges, it doesn't matter which order you put. If you put C as node 1, B as node 2, or B as node 1, C as node 2, it's exactly the same because these are all undirected edges. And we can set the values. So for variable elimination, the click potentials are going to be pretty important, and the click potentials depend on which assignments can each variable or each node in this Markov network take. So for each node, we can specify the name of the node, so let's say A, and then the values that it can take on as a comma separated list. So A, let's say, can only take on value 1. B can only take on values, let's say 1 and 2, and maybe C can take on value 1. And we see that these node values show up in the table below. And now we can define our click potentials. So the assignments we define as this depends on which variables are in the click. So let's say we want to define one click that's variables A and B. So we would say A equals 1, B equals 1. Maybe we say potential value 0.2. Then we can say A equals 1, B equals 2, potential value 0.3. And then we can say C equals 1, B equals 2, maybe 0.5. C equals 1, B equals 1, 0.4. So now our potentials table looks like this. And now we can run variable elimination. And let's say we want to eliminate variable B. So let's notice a couple things. One, we see that the variable B is gone from the network, and nodes A and C now get connected as part of the induced graph. Also, we see the potentials table is now replaced with this new potential, and the derived potential table is replaced with this. And here the potentials table and derived potentials table is exactly the same because all of the potentials in the original table involved node B, and those all got marginalized out. And so the derived potential is the same thing that shows up in the potentials table. So this was kind of a simple example. Maybe we can show a little bit more tricky example with the student network, which is kind of a really popular network that's shown in Collar's textbook. And here I've kind of described it as a Markov network, but note that you can fully describe any Bayesian network with the Markov network. So I actually defined it exactly the same way as I might have defined it for conditional probability tables, but just specifying the conditional probability tables as these click potentials. So one thing I can do, let's say I want to run variable elimination on it. Before I just ran variable elimination with one variable. Here maybe I can just specify a comma separated list of nodes. Maybe I'll say S, G, D. I can press run variable elimination. And then look at what happens with the derived potential table on the left as we do this. We see that for each basically variable we eliminated, for a short period of time it flashes what are the derived potential tables as a result of that. And that can just kind of help us trace through the logic of what's going on. And so then we can kind of at the end see the potentials table, which has all of these derived potentials as well as some of the other potentials that were in this originally, or that were derived from other eliminations. Okay, and yeah, so if you have any feedback on this, that'll be much appreciated. Go to the PGM Learning homepage and then feedback button and just enter in any feedback, and I'll be happy to fix anything that might not be working perfectly.